Okay, and then this one has nothing to do with quadratic equations. It's something we kind of haven't really been teaching. I personally think it's kind of useless, but the state government doesn't agree with me, okay? So, sorry, I work for them. I want to review absolute value real quick, and this assignment we don't even need a calculator for. Absolute value of 3 is distance from 0 on a number line, so 3 is 1, 2, 3. Negative 4, when to get to 0 you'd count, it's just counting, 1, 2, 3, 4. Don't put negative 4, it's 4. Absolute value of negative 6, 1, 2, 3, 4, 5, 6. Okay, so 6, 2, 1, 2, that's 2. Negative 5 to 0, 1, 2, 3, 4, 5, 5. 5 to 0, 1, 2, 3, 4, 5, 5. Notice how these are the same answer. Negative 6 to 0, 1, 2, 3, 4, 5, 6. 6 to 0, 1, 2, 3, 4, 5, 6. Okay, pretty interesting, I know. Now, ignore that stuff right there. Okay, ignore that. Now I want to graph this absolute value equation. You've never done that before. First you're going to use a table, and let's just pick 5 points. Let's pick 0 in the middle and go negative one way, just to negative 2, positive the other. Now if I put negative 2 in this absolute value, okay, let's say I substitute negative 2 for the x. What's the absolute value of negative 2? Well, 1, 2. If I substitute negative 1 for x, the absolute value from negative 1 to 0 is 1. If I substitute 0, that's 0 because you're there. Now what happens if you substitute 1 for x? Well, you're still getting to 0, 1 unit. Okay, so how many units from 0? So yeah, we're back to 1. 2. 2 is 2 units from 0. Okay, graph that. Remember, this is x, this is y. So I go left 2 up 2, left 1 up 1, and then 0, 1, 1, 2, 2. Okay, what we have there is a V. Okay, it is a V. It's kind of like a line, but then there's a vertex. Vertex is where it stops. Okay. Now, that is called the parent function of absolute values. You don't have to write this. Parent function of absolute values. Okay, that's what that's called. Okay, now I want you to graph this without using the table. So let's put 0, 0. How an absolute value behaves. It's right 1 up 1. Left 1 up 1, right 2 up 2, left 2 up 2. Okay, so that is how you graph an absolute value function. I showed you why because of here. Okay, that's called your parent function of absolute values. Okay, now what you're doing today is transforming absolute value functions. The point of it, that's a good question. Ask the state government, okay? Okay, y equals the absolute value of x plus 3, okay? First off, graph the parent function of absolute values. When I say that, you go right 1 up 1, left 1 up 1, right 2 up 2, left 2 up 2. Okay. Don't graph that though. You have to do what's called a translation. Okay. This plus 3 is outside the absolute value. It's called a k value. Okay. K values mean we translate it up or down. Well, it's plus 3, so we translate it up 3. Here's how you translate the function up 3. Take that vertex, go up 3, and then do your little right 1 up 1, left 1 up 1, right 2 up 2, left 2 up 2. Okay, and then there's my function. It's just 3 units up. Okay. Okay, now the next one. Graph your parent function of absolute values. Right 1 up 1, left 1 up 1, right 2 up 2, left 2 up 2. We have a translation to make. It's outside of the absolute value. It's called a k-value. Then the translation is vertical, but since it's minus, it would be down 3. Translation's down. So 1, 2, 3. Right 1 up 1, left 1 up 1, right 2 up 2, left 2 up 2. Okay. You don't even need to use a ruler if you don't want. Okay. Next, I'm going to cross this one out. Not in the mood for decimals. Okay. So make your parent function. Right 1 up 1, left 1 up 1, right 2 up 2, left 2 up 2. And go ahead and not connect it because you have a translation to make. You need to translate that v, that function, up 5. That's a k-value. If it's inside the absolute value, it's not a k-value, okay? You'll see that here in this bit. It's going to go up 5, okay? 1, 2, 3, 4, 5. And then same behavior, though. Boom. Okay, next one. Absolute value of x plus 2. Parent function of absolute values. But you have a translation. That's a k-value. K-values were vertical, so we translate the graph up 2. Okay. Take your vertex up 2, right 1 up 1, left 1 up 1, right 2 up 2, left 2 up 2. Boom. Okay. Parent function. Okay, and then that's a k-value, so you're going to translate it down 7. Okay, so 1, 2, 3, 4, 5, 6, 7. Right 1 up 1, left 1 up 1, right 2 up 2, left 2 up 2, and that's the function. It's just like you're taking every one of those points down 7. Now, the game changes in the next one. Get that 0.5 out of there. Okay. Now, make your parent function of absolute values, same as before. There's your parent function. Now, this time the plus 2 is inside. Then it's not a k value. Okay. It's called an h value. H values move horizontally. Okay. But normally you think a plus is moving to the right, but inside the absolute value, it's opposite, okay? So you're going to translate, but instead of plus 2 right, everything inside is opposite, just saying it like that. Inside is like where everything becomes opposite. So you're going to translate left 2. Take that vertex, move it left 2. Up 1, right 1, there's already a point. Or right 1 up 1, left 1 up 1, right 2 up 2, left 2 up 2. Okay, so it shifts. Okay, next one, parent function. Right 1 up 1, left 1 up 1, right 2 up 2, left 2 up 2. Okay. Now you're inside. Okay, inside is horizontal. Okay, but inside also, the translation is horizontal, not vertical, right to left. But inside is opposite. We normally think a -6 going this way, but inside goes the other way. So you're going to translate it right 6. 1, 2, 3, 4, 5, 6. Right 1 up 1, left 1 up 1, right 2 up 2, left 2 up 2. Okay. And there's a function. Okay. Pretty exciting stuff, let me tell you, man. Okay. Okay, parent function, right 1 up 1, left 1 up 1, right 2 up 2, left 2 up 2. Okay, you need to do a translation. It's inside, so that's an H value. Remember, K values are up and down, and the K values aren't opposite. Outside is just normal, okay? But inside, I normally think of this way as a horizontal movement, okay? But actually, it's the opposite way. Translate it right 3. So 1, 2, 3. Okay. So you go right 1 up 1, left 1 up 1, right 2 up 2, left 2 up 2. Okay, next one. Okay, parent function, right 1 up 1, left 1 up 1, right 2 up 2, left 2 up 2. Okay, just like that. Now this is an H value, it's inside, it's horizontal, but horizontal is going to go the opposite way of what we think. We normally think +1 is this way, but we translate it the opposite way. We reverse course, okay? Now I'm going to explain here in a bit why you reverse it, okay? So, just go left 1, then right 1 up 1, left 1 up 1, right 2 up 2. Sometimes you have to go really focus on between because you run into your parent function. Now I'm going to explain why you reverse it. Okay, this coordinate is -1, 0. Okay, that's what that is. Well, if you put -1 in for x, what's -1 plus 1? That's 0. And then the absolute value is 0, 0. Okay. So it's like you're trying to get 0 inside of it at the vertex, okay? And the way to do that is opposite inside. Okay, now this one's a little different. There's a negative sign circled. What that means is you invert the parent function. It means you go right 1, down 1, left 1, down 1, right 2, down 2, left 2, down 2. So it flips the graph, okay? Now there is a translation. Okay, that is a K value, that's outside, so that's going up 4. K outside, you do what it says, it's vertical. Okay, now take that 1, 2, 3, 4, right 1, left 1, down 1, okay, and then the same behavior. So the negative in front inverts it. Okay, negative in front, so the parent function, instead of right 1 up 1, right 1 down 1, left 1 down 1, right 2 down 2, left 2 down 2. Okay. Okay, now you have to translate it. This time the +2's inside, so that's a H value. Okay, H value is horizontal. Okay. But inside you do the opposite of +2, which means you're going left 2. Okay, so take that, move left 2, and then the same stuff. Right 1 down 1, left 1 down 1, right 2 down 2, left 2 down 2. Okay, and there we have it. So that's how the negative works. Okay. Okay, now this one you actually have both an H value and a K value. So you graph your parent function, right 1 up 1, left 1 up 1. There's no negative, so I'm back to going up. Okay, and we translate it. Well, you got two translations to make. The K value means you're going to translate it down 2. And the H value means you translate it horizontally, but left, okay? Down 2, left 4. So take that vertex, go down 2, left 1, 2, 3, 4, and then you do your thing. Right 1 up 1, left 1 up 1, right 2 up 2, left 2 up 2. Bam. Okay. Okay. Translate. Okay, first make your parent right 1 up 1, left 1 up 1, right 1 up 2, left 2 up 2. Okay, then you translate it. Now that's an H value, that's a K value. The K value does what it says, that's a vertical shift. Okay, it goes up 3. The H value does the opposite of -2, which is add 2, which means moves to the right 2. Okay, so up 3, right 2. It doesn't matter which one you do first. Right 1 up 1, left 1 up 1, right 2 up 2, left 2 up 2. Okay. Okay, obviously that's not a lot of work.